Hi, scholars. Welcome back. We are continuing through our first section of Chapter 3, Section 3.1.1. Today, we are focusing on question 3-4 and 3-5. Okay, to begin, let's do a quick review of what we were learning yesterday. We learned yesterday about the multiplicative identity, otherwise known in CPM as the giant one. Here's our giant one. To help us remember, the giant one, or the multiplicative identity, is any number or expression that is multiplied by the number 1. The result is equal to the original number or expression. That number 1 is called the multiplicative identity. Okay, down here, again, we have our big idea, which is when you multiply any fraction by a 1, by the giant 1, you will create a new fraction that is equal to the original fraction. To help everybody kind of get a better understanding of the multiplicative identity, I'm going to give you one example where we're not using fractions, we're just using good old numbers, okay? So I'm going to choose to multiply the number 3 times the number 1. So right here we are watching, I am using the multiplicative identity, and I know that 3 times 1 is 3. So let's look at the definition again and look at what I did and talk through this. So we have any number, the multiplicative identity is any number, so here's our number 3, or expression that is multiplied by that number 1. The result is equal to that original number. So 3 times 1, this number is equal to this, okay? And that number 1 is called the multiplicative identity. The way it changes with fractions is, as we have learned, just like I was talking about yesterday, you have a pie and you've sliced it into 7 pieces and you haven't taken any of that pie out. You have still one whole pie, even though it's in 7 pieces, okay? So that is where, and so it's 1. So that is how it's different when we use fractions. So that's where the big idea comes into play. When you multiply any fraction by the giant 1, you will create a new fraction that is equal to the original fraction, just like I did here. Okay, moving along, today we're going to spend some time looking at 3-4 and 3-5. I will give you an example for each, and you will set off and work on these items independently. Okay, so for 3-4, I'm going to read it to you. It states, use that idea of the giant 1 and find at least 4 fractions that are equivalent to 9/8. Okay, so I'm going to write my 9/8 down here and multiply. Here's my giant 1. Okay, so I'm going to choose for my example, I'm going to use 2. So I'm going to put 2 2s and think about it, how that's a whole. If I had a candy bar, one whole candy bar, and I broke it into 2 pieces and gave you both pieces, you still have one whole candy bar. Okay, so that is where the multiplicative identity and the giant 1, that idea comes from, okay? So now let's multiply these and find out what the products are. So 9 times 2 gives us a numerator of 18, and 8 times 2 gives us a denominator of 16, okay? So what you could say is that 9/8 is equal to 18/16, just like with that idea of the multiplicative identity. We've multiplied it by a 1, albeit 2 2s, so 9/8 is equal to 8/16. Okay, you will, once we leave our video, you will go and you will complete the rest of these independently. So moving on to or 3-5, excuse me, it states, so many choices. Says, Bertrand was feeling very confused. There are so many ways to write the giant 1. How do I know which one to use? He whined. How can Bertrand decide which giant 1 to use? Work with our team, or in this case independently, to answer the following questions and come up with a strategy. So I'm going to do I, and you will work independently and complete I, and I, and answer question B. So it states, I. So they have here, I'm going to write it down here. This, this reminds me of 3/4 times. This kind of looks like, guys, what we were using, what we were solving, and how we were solving with the generic rectangle puzzles. So see how, remember how in the generic rectangle puzzles, they gave us parts of an answer. They would give us a product and some factors, and we would have to be problem solvers and figure out, use those clues to come up with the missing factors and sometimes products. So it's kind of the same thing here. We have been told that the denominator for the answer, the product, is 44. So we just need to figure out how many times we're going to be using the reverse operations, okay, which is division. We're going to be using the reverse operations. We're going to ask ourselves, how many times does 4 go into 44? So we could decompose 44 into 40 and 4. And I'd say, I know for the ones that 4 goes into 4 one time. And then 4 goes into 40 10 times. So in the tens place, I'm going to have another 10. So remember what we learned, that in order for it to be considered a giant 1 and be equal, the numerator must be the same as the denominator. So since we were able to find this piece, this missing puzzle piece like we did last week, we know that the numerator will be 11. So 3 times 11 is 33. Okay, so our answer for I is 3/4 times the giant 1, which is 11 11s, equals 33 44. Now it's your turn. You're going to complete 3-4, question 19. I've already given you one example, so I need you to complete 3 more examples and then answer the question below. And then for 3-5, I already solved the first question for you, but I need you to solve I and I. And here I want you to describe this information, but I'm also going to have you create a Flipgrid video explaining to me your understanding to date, right now, of the multiplicative identity, or better yet, the giant 1. Okay? So what you can do is you can compose what you want to say here, and then when you go over to the Flipgrid, you could read it. As long as I am hearing your understanding, that's what I'm looking for. As always, scholars, I am here to support you. If at any point you need help and you don't feel like you understand, just come back into the meeting and I'll be here for you. All right, good luck. Thank you. Bye.